Tēnā koutou katoa. Greetings and welcome to old Rivera friends and new Rivera friends. There are a few friendly faces in here. Thank you for making time to come out today in this weather. We appreciate it. I'm Neil, I'm the Wellington Sales Manager for Rivera, and today we're supported by our good friends at CCL, somewhere in the room, and Hitachi Vantara, some of whom have travelled from a good distance to be, be here today. When I was prepping for this today, I did a bit of an internet search just to get prepared, and I found a few stats on the internet which blew me away. One of them, only 0.5% of the data ever produced is actually used or analysed. And another stat that jumped out at me was next year in 2020, it's likely that 1.7 megabytes of data will be produced every second for every human being on this planet. So okay, there's quite a bit going on there. What are we going to do with all this data? The other searches that came up were the usual suspects: big data, AI. What that means to me, big data, Facebook, checking what I'm doing to do targeted advertising, AI, my Alexa, Amazon Alexa at home, turning lights on and off. Then we come up with machine learning and analytics. Machine learning, Spotify, when I'm listening to songs, it's suggesting playlists for me based on what I listened to yesterday. And analytics. And I thought about analytics, and I got thinking about the stuff that I do every day and the things that we all do every day. We're all doing analytics. I produce a spreadsheet that goes to Department of Internal Affairs once a month. It's an Excel spreadsheet, and it's full of tables and charts and graphs. And it takes me and a colleague hours to do it every month. I was thinking, well, what about if I could run a tool that just does this in seconds for me? That would be cool. I need to talk to you about that after. So we're all doing analytics, and that's really what today's about. Rivera's mission, one of Rivera's missions, is to produce platforms and software that helps you derive benefit from your data, deal with the 0.5 of the 1% and make sure that we get that up a bit, and empower everyone in this market, in this room. Call to action today: please listen, learn, and take back what you hear today back to your office. We're happy to have these conversations as required, because this is obviously big and much bigger than where we started with the infrastructure 12 years ago. I'm going to introduce Akash. He's going to kick things off today. And excuse me while I read from this, because I don't want to do the guy a disservice. He's got some a good little bio here. Akash incubated multiple lines of business within ANZ, including Cisco Spark, Telstra Cloud Collaboration, and Rivera's ETL product. Akash built Australia's first security-focused big data platform as a service product in Telstra, and with Curious, over here, launched a Hadoop as a service product to market. Akash currently works for Rivera, helping the business extract value from data and incubating products with a data and digital portfolio. He sounds like he's qualified for the job today. Akash, please come up.
Where's the button for this? Bottom. Hello? Yep. Great. Thanks, everyone, and thanks for the intro, Neil. Today is going to be an educational session for everyone. We're going to be talking about use cases, we're going to be talking about methodology and a whole bunch of things, but the key thing, as Neil highlighted, is taking this back and asking the questions back into your business about what's possible and what could we do differently, and that's extremely important. Now, we've called it the next chapter, so let's first explain why it's the next chapter. In terms of this is my view, okay, of what next chapter means for New Zealand and the industry. As highlighted, my experience has been in Australia and New Zealand. I've been in the big data machine learning space for roughly 5 years now, okay? And I've made a lot of mistakes, but I've also had a lot of success on the way. Especially with new open source technology, you do have to make mistakes on the way. Now, the next chapter for organizations and businesses in New Zealand and globally is really built off a couple of things stacking together, okay? The first transition that occurred and Mark Hall is going to talk about this in detail from a machine learning perspective, is cloud, okay, and computing. So very simple, CPU, RAM, and storage, okay? Now, cloud has made this easier to consume. So you can go into Amazon or Google or Azure and put your credit card down and start consuming services fairly quickly. So it's it's about the speed of access, but it's also about the consumption model and how you pay for it, okay? So I think that's been a compelling factor for most businesses around the world. Number two is, this is a silent revolution, I would say, is open source. So open source is I call it a business model. But really what it brings is benefits, not just free stuff. It does bring you free stuff, that's true. But it allows you to do innovation and get innovation from anyone around the world. So you yourself could be a developer coding and committing code to a product. And that's how open source works. It's all about innovation, agility, and less vendor lock-in at the end of the day. But the other thing that sort of evolved over time is open data, okay? It is a word that's widely used nowadays, but open data was kind of created from cloud because the low cost of infrastructure, but also open source software usually drives open data environments altogether. And open data has created the ability, or has created the definition of new skill sets, which I want to talk about in the industry. The third thing is data analytical platforms. Now, data platforms have existed 50, 60 years, okay? Mainframe is a data platform at the end of the day. But it's the modern data platforms that do things differently. So I really look at the 3 V's, so, volume, variety, and velocity, which I'm going to talk about in a bit more detail. But that's what I think a data platform is nowadays. And the last thing, which is a discipline, or the revolution has been created, is basically all 4 elements stacking up together. So the cloud, open source, the platforms, creating the ability to do machine learning at scale. Mark's going to explain how machine learning is there and back again. So it's existed for years and years and years, okay? And IoT is a new way of getting data and a source of data. And it's also about real-time. Unfortunately, I can't walk too far that way or this way. But it's about getting new sources of data quickly when you need it. So that's the next chapter, but as we know, technology is just one factor in evolution. It's always about people at the end of the day, which creates processes at the end of it. So the next thing is DevOps. So as you understand, with cloud, DevOps, which is automation and mindset, I call it agile for technical people at the end of the day. That's what DevOps is to me. Okay, it's a way of working differently. But yes, there is Ansible, Chef Puppet, and a whole bunch of things that wrap around it. But that's the first factor that cloud's created. Number two, with open source and open data, it's created this data scientist as a definition, as a word. And if you really look at Google Trend from a stats perspective, data science was only created roughly straight after Hadoop was created, after HDFS and open source products were created. Okay? And that is also a new sort of definition that's still maturing in most businesses. I've yet to see one definition of data science across the board. Now, the one that in New Zealand we don't really value is data engineering. Now, data engineering, I went to Strata Hadoop World 2 years ago in New York. The job board had 80% of the jobs were for data engineers, 20% were for data scientists. So it flipped. The reason is you need someone to build that platform, to get it ready, to scale it out, and to write it so you can actually operationalize it, and to move the data around. And that's what a data engineer needs to do. So a data scientist actually can't do anything until the data is ready. So you need to get the platform ready and the data sets ready. And that's what a data engineer does, hygiene. And the last thing, which is once you enter the machine learning world, and we'll go through this with Mark, is it's not just about the technology and the skill sets, it's also about the methodology and the approach of delivering machine learning. It's not something that you set and forget. It's a continuous investment by businesses. And data ops is what I call it. I have yet to see an organization in New Zealand that's done data ops properly. We had a go when I was in Telstra at creating a data ops environment. There's no perfect definition for it, like DevOps or Agile too. But data ops is about managing everything with a team of data engineers, data scientists, and cloud specialists wrapped around it. and it's about serving the business, okay? So the key difference between DevOps and data ops is DevOps builds systems, okay? Data ops builds business outcomes because they focus on the data, and the business always owns the data. That's the big difference. So it's a slightly different mindset. So that's what I think is the next chapter, is technology, the evolution, the stack-on-stack effect, but also new skills that are emerging in New Zealand, and new skills that have to be nurtured and created in New Zealand as part of it. So what does this give you? It gives you agility. So cloud gives you agility, but with the data ops, you get agility from a data perspective and self-service analytics, insights, a whole bunch of use cases. But you get new business models. So if you look at organizations around the world, a lot of them have created new business models through big data and machine learning. Machine learning is usually a new business model for organizations. Look at, I'm just going to use Uber as in this example, because everyone uses it. But Uber is a business model. Their predictive pricing or search pricing, whatever you want to call it, is basically using a machine learning stack with big data wrapped around it and delivering a predictive price point that's disrupting the taxi industry. So some of these are actually what Neil highlighted. So what are the experts stating? And these are from Forbes, Gartner, Forrester. I have turned this off, have I? Yep, I have. This is something that probably is quite an eye-opener. Now, the question for you is, you probably have this challenge at home on your personal laptop or on your personal PC or with your family, okay? So the first statement is data will double every 2 years for most organizations and enterprises, okay? So how do you prepare, how do you manage, how do you look after, how do you extract value from that data? Because it is going to double. My Google Photos doubles every three months, okay, in terms of space. So that's a challenge I've got at home. Less than 1%, as Neil highlighted, of unstructured data is being analyzed. Okay? So what value are you leaving behind? All these other organizations are extracting data externally and creating new business models and differentiating themselves. Are you doing that right now? 70% of data will reside outside your business firewalls by 2022. Okay? So that means you'll have more open data. It's not about paying for Facebook and Twitter data. It's not only about that. But government and organizations are opening up data more and more. And it's not about New Zealand government. You might access data from external government agency. So you'd use that to enrich it and build value. Are you doing that right now, and are you prepared for that? The last one, nearly 90% of the world's data has been created in the last 2 years. Okay, so do you actually have access to data? Do you actually know where your unstructured data is? If you've got an application, you're already creating unstructured data. Are you using that to understand clickstream behavior or buyer behavior right now? So these are what the experts are saying. So it's something to take back to your business and think through about what value you're leaving behind by not using unstructured data. Now, modern challenges with data. I'm going to keep it very simple, 3 Vs. There are 7 Vs, 9 Vs. There's different flavors that move around all the time. And this is basically talking to roughly 50 to 60 customers in my journey in Telstra, but also talking to a lot of New Zealand customers. I think I've talked to about 120 customers in New Zealand to date. And the challenges are really three, starting with volume, okay? Now, volume is not about finding a petabyte of data, then figuring out how I'm going to analyze it. It's not about a petabyte of data, okay? Volume is very simply kind of building a data lake in a very simple form, because the data lake term can be different for individuals. But it's about removing silos and improving accessibility to the business and to yourself with data, okay? It's extremely hard getting a spreadsheet out of a person, correct me if I'm wrong. And then it's extremely hard getting that spreadsheet continuously out of a person every couple of weeks, okay? That's the challenge you face. I'm sure everyone faces that problem right now. So what you do with volume is you improve accessibility and then you automate it. Number 2 is variety. Variety is about accessing data sources that you don't have or didn't know it existed before. If you've got an application, you will be creating weblogs, okay, which is quite powerful information about your customer. Are you using it? Have you created an analytical insight environment for it? So a lot of the traditional databases like SQL or relational databases or data warehouses don't really support unstructured data. And you wouldn't want to do it anyway. You can do it, you can retrofit it, but it's going to come out to be a lot more expensive as it moves into production. So that's where you think about NoSQL databases or object storage. So that's the challenge that most businesses face, is they don't have the technology or the databases or the data stores to support unstructured data. Now, the third thing is real-time access. For certain use cases that we're going to talk about today, is you want the ability to bring in data sets fairly quickly, analyze it, delete it, or aggregate it, or move it, archive it straight away. And that's another challenge that businesses face, especially in IoT. You want real-time access. You might have billions of events coming in, and you need the ability to queue it and message it and aggregate it. So that also falls in the variety stack. It's not just about bringing unstructured data, it's about the speed you bring it into the business. The last one is velocity. Velocity is really, the first thing I would define in velocity is self-service analytics, okay? Every person in this audience probably wants self-service analytics, okay, from their data sources. And that is extremely, extremely important. And that improves decision-making process, it improves visibility. There's so many benefits that you can get out of it. So Anton, who's going to present later, he's our BI data scientist, and he's done a lot of self-service analytics within Rivera. And it's just made a huge difference in terms of visibility across the board. And the last challenge that most businesses have is slow insights. So if you've got a data warehouse, the cost to process data, to deliver an insight, actually, I'll give you the stats. So the cost to build a report in the BI space is between $150,000 to $250,000 once you add everything up, resource costs and hardware and data warehousing. And you get a report usually on average between 2 months to 3 months down the track. Okay? Once you feed into the factory, that report may not be the report that you wanted, or might be too late to make that decision. So that's a challenge that we faced in Telstra. And that led us to our big data investment to actually simplify it. So with slow insights is you can use Hadoop solutions to optimize things quite dramatically. So one of the we're talking to one of the Portugal Hadoop specialists, reduced a 5-week processing time for one report down to 5 minutes by using modern technology. So people actually could do a lot more insights, could deliver more insights, and the business can get insights in 5 minutes. Cool. So that's just simple things that's probably the simplest use case with big data, machine learning, and cloud, is just optimization, increasing speed to insight. It's a lot faster once you get it right. Now, what value do you get out of this, or what are the benefits you can gain as an organization? Now, the first one is customer engagement. Okay, customer 360, patient 360, it could be asset 360 in this situation. But really, in its very simple form, is know me. So I break it into 4 areas: know me, understand me, engage me, and delight me. Okay. Now, this little device here is delight me. So it's a Google Home device that you can talk to. So you say, "Okay, Google, play some music." But organizations aren't there yet. Want to turn it off? There you go. Okay, so Google and Amazon have the data and the skill sets to deliver that delightful experience. My mum still has problems with it when she's trying to play music with it. I'm sure you guys do. So she does have anger management with the Google Home a lot. But businesses in New Zealand and Australia is still at that know me and understand me. So that's one of the first use cases you want to do, is understand your customers, your citizens, your patients, and then you can move into a delightful experience after that. And there's thousands and thousands of use cases around that, especially around banks using social media to actually deliver a better way of personalized experiences back to their customers. Even doing credit scoring by not even talking to you, because they can extract or scrape data from the internet fairly quickly, bring it in, and have the ability to say whether you're a risky customer, high-risk customer, or low-risk customer. Second one is operational excellence. Operational excellence is all about agility. So usually it is cost out. So productivity is cost out in my definition. So that would also fall in here. And this would be things like it could be simple things like moving it from a very expensive storage environment to a low-cost storage environment. So the cost to store in a data warehouse is around 30,000 Australian dollars per terabyte. In an object storage or an HDFS architecture, It could be 1/5 to 1/6. We managed to get 1/10 out of it. Okay, so you can reduce costs quite quickly. But self-service insights fits under operational excellence. It's about the business making them move faster with their own data usually. The next one is reduce business risks. It's about granularity. So instead of having aggregated data, and Mark Hall will talk about machine learning and aggregation of data, you actually get access to raw data. So you can ask the questions that you wanted to answer, and you've got access to those data sets to ask those questions. Okay? Once you aggregate on a spreadsheet, you lose a lot of information. Okay? And it's individually driven straight away. And also compliance lakes. So compliance lakes are if you're regulated and you want the ability to store data for a very long period of time, so 13 to 7 years, depending on which country you're in, you have the ability to store it, but not only that, but do data lineage. So understand how it's stored, who's accessed it, who's updated it, who's deleted it, who's modified it. You can actually track you can audit the entire history of that data once it lands into a lake. And innovation is really new business models. So one of the Hitachi use cases is basically one of the regulatory bodies in Europe now gets 20% of its income through data sharing. They created a new business model out of it. Okay? Uber's created a new business model. Airbnb's created a new business model. And all of these guys use this technology underneath. Now, I'm going to stop there, and I'm going to hand it over to Mark Hall, who's our guest speaker. So Mark is one of the unsung heroes in New Zealand, lives in Roadshow. He developed Weka. And to me, Weka is it's a symbol for people in the data world. Because data scientists weren't really born till roughly 2008, 2009, okay, as a discipline. But Mark was doing all of this in the early 90s, okay? So he created tools and technology that actually defined what data science is today for the world, not just for New Zealand. So it's really nice to have someone like Mark talking with us today. I'll hand it over to Mark. Thank you.
Great, thanks, Akash. Can I have the clicker as well? All right, yeah, it's really good to be here this morning talking to you guys. As Akash said, I have quite a history in machine learning. I started my journey at the University of Waikato as a graduate student working on a piece of software called Weka, and I'm going to talk a little bit about that to begin with. And then I'm going to move on and speak a little bit about kind of my view of machine learning, why machine learning is hot today, and what you kind of need in terms of a platform for machine learning. So I've entitled my talk Machine Learning or There and Back Again because I was struggling for a good title for this talk. So I'm hoping that the talking reference in there, the or there and back again part, will become apparent as I move through my talk. So I mentioned Weka. Weka is a piece of software that came out of the University of Waikato in the early 1990s. So exactly what is Weka, I hear you asking yourself? Well, apart from being a native bird of New Zealand, it is also an acronym. It stands for the Waikato Environment for Knowledge Analysis. Now, what that is basically it's a machine learning workbench. And as we know, machine learning is a subfield of artificial intelligence, a very applied, practical subfield of artificial intelligence that is concerned with learning from large data sets, empirical learning from large data sets. So what Weka has is a collection of machine learning algorithms, all written in Java. And the main types of problems that it can tackle are classification, regression, attribute or feature selection, and clustering, and to a lesser extent, something called association rule mining. Now, Weka has a simple, easy-to-use API for developers. It has a full-featured command line user interface for script kiddies that like to script stuff. And it has a number of graphical user interfaces which make it easy for the software to be used by folks who are new to machine learning. Some of the screenshots of Weka are shown there at the bottom of this slide. However, that's today. Now, back in the day when I got interested in machine learning over 25 years ago, there was a group of people with a developing interest in this new technology called machine learning at the University of Waikato in the computer science department. And we took a look at the state of affairs in the academic community, at least, with respect to what was available in terms of software that a budding researcher could get their hands on in order to generate a piece of research, right? A bunch of numbers for algorithms that they could get published in a journal or a conference. And it became apparent that whilst there was a number of pieces of software freely available out there, it was quite a steep learning curve and a large undertaking for folks to get hold of this stuff, get it compiled on their local systems, and deal with the different file formats that these different pieces of software required, and then finally start to generate some numbers from the state of the art that they could compare to their new method in machine learning and get a publication. So the group, newly formed machine learning group at Waikato, decided to apply for some money from the university government, from the government of New Zealand, I should say, in order to develop some software to aid researchers. So we applied for funding for doing this from an outfit called FOREST, which stands for the Foundation of Research in Science and Technology. It's no longer around. And we were successful in getting some funding, and the goal of the project then was to produce this software and also to investigate how machine learning could potentially benefit the New Zealand economy, in particular the agricultural industries. So we began developing this software back in 1993, coined the acronym, settled on a standard file format for it, and we had an internal release of the Weka software for folks to use inside of computer science department and other departments in 1994. And it really wasn't at this stage ready for public consumption. As we can see from these somewhat humorous entries from the change log for that piece of software, that release at the time, things such as unambiguous and unsupported menu commands removed, crashing processes handled in most cases, kind of stuff that really instills confidence in your user base. So we held off on releasing it and worked some more on it for another couple of years and had a public release of this software towards the end of 1996. This was Weka version 2.1. And at that stage, it comprised a bunch of algorithms, like I said, that we'd collected from researchers around the world. Most of it was written in C. There was some in Fortran, a bit of code in the logic programming language Prolog for rule evaluation. And on top of it all, we built a user interface, rudimentary user interface in something called TickleTK, for those of you that remember Unix systems. So the whole thing ran on Unix systems and these newfangled Linux boxes that were popping up at the time. Now, it became apparent to us very soon that that something funky has popped up on the screen. I don't know where that came from. I'll let Anton fix it for me. So it became apparent to us with Weka that it was going to be somewhat of a challenge to support this project moving forward simply because of the dependencies on various flavors of Unix and Linux libraries that the software required. It was difficult, well, somewhat difficult to get it to run on, users' systems, different configurations, and so forth. So in 1997, towards the end of the year, we made the decision to rewrite this software entirely from scratch, all the algorithms, everything, in a brand new programming language called Java. The write once, run anywhere promise of Java seemed like a godsend for managing the project moving forward and supporting it. However, most of our colleagues were busy rolling around on the ground laughing their asses off, right? I mean, saying things like, why the hell would you want to write scientific computing software in a language that is interpreted and runs 30 times slower than C? At the time, there was no just-in-time compiler for Java. However, being stubborn, we moved forward with this, and basically it was the best decision that we could have made. In mid-1999, we released Weka 3.0, 100% Java, and it accompanied a publication of a new book on machine learning by Professor Ian Witten from the University of Waikato and his then graduate student, Iber Frank, my colleague Iber Frank. And if we sort of fast forward through to today, that book has proved to be very popular as a course text. There have been 4 editions of it now, the most recent one in 2016. Each edition of this book has coincided with a stable release of the Weka machine learning software, with development releases in between. In 2005, the team and the software received a service award from SIGKDD, which stands for the Special Interest Group in Knowledge Discovery and Databases. So this is a very prestigious award. We were pretty chuffed to receive it. 2006, a new company by the name of Pentaho acquired a commercial license to embed the Weka software in their greater overall open source business intelligence software offering. 2015, Hitachi Data Systems came along and acquired Pentaho, along with the agreement that exists between Pentaho and the University of Waikato with respect to Weka. Now I work for Hitachi Vantara Labs, formerly Pentaho Labs, and we can continue contribution to and innovation with Weka. We can see a download chart here for Weka, the Weka software from the SourceForge platform. It's a platform for disseminating open source software. We put Weka on SourceForge in 2002 when it was a brand new platform, and since then we've seen linear growth in downloads and 10.5 million downloads to date. Now, as a little aside, Weka was being initially developed at the same time a little-known piece of software called R was being developed at the University of Auckland. So somewhat a nucleus for statistical and machine learning software here in New Zealand. All right, so that was machine learning back then. How about machine learning today? Why is there such a huge interest in machine learning? Why has it really exploded over the last couple of years? I don't think anyone disputes the fact that machine learning has a large potential to impact society in all walks of life. So why is this happening now, and why not back in the day? Well, there are a few reasons for that. Part of it revolves around an interest in basically what is the third resurgence of neural network software. So deep learning, you may have heard of deep learning. It is a hot topic at the moment. Everybody wants deep learning, regardless of whether they actually need it or not. And it drives a lot of the applications around video and image processing, sound, unstructured data. So there is the hype around deep learning. But really what it boils down to is basically an increase in computing power and a decrease in cost and ability to store large amounts of data. Right, so many of the sophisticated machine learning algorithms, even like the nucleus, if you like, or the basics of deep learning, have existed for a very long time. Some of it dates back to the 1950s. Right? However, back in the day, it was not able to realize the true power of these algorithms because of the lack of computing power. The computational complexity of the algorithms was such that they could not be applied on the hardware that existed at the time on anything but very small toy data sets. The other side of the problem was that data wasn't being stored, right? It was not economic to store large volumes of data. What was being stored was heavily aggregated at a very coarse level of granularity. And when you have that sort of a situation, you get equal performance basically out of a very simple method or a simple algorithm as you would out of a sophisticated algorithm. So we couldn't realize the value of these more powerful techniques on real problems. So abundant storage and computing power, ubiquitous computing these days, everything has a processor embedded in it, it's connected to the internet, it's generating data. And more so than ever, there are tools, APIs, frameworks, libraries, and so forth for machine learning that folks can use. So how do we realize the value of all of this? There is a lot of choice facing organizations that are perhaps interested in trying to operationalize machine learning and reap the benefits. From the development standpoint, like I said, there are a lot of libraries and tools around that your data scientists can use to develop the models that drive the predictions that your business needs. Data formats and structures, less of an issue these days than it was in the past when we were trying to originally develop the Weka software. And then you've got the nature of the applications being developed. So are we going to be looking at developing an application based on machine learning that's going to operate on streaming data, right? Does it need to be a near real-time system? Is it going to run perhaps on limited hardware out on the edge in an IoT application where data is streaming from sensors or perhaps coming off of some sort of message bus? Or instead, is our application going to be more on-premises, batch-based on large volumes of data that is collected overnight or weekly? Are we going to run it on premises, or perhaps are we going to try and leverage the benefits of cloud and the elastic computing that such providers provide, basically. So are we going to run it out in the cloud? Are we going to run it on bare metal, or are we going to take it into virtualized containers? All of these questions have to be addressed by organizations trying to leverage these kind of applications in machine learning. And to a certain extent, there is paralysis can set in, right? You know, what if I make the wrong decisions today? A couple of years down the track, we're going to develop new applications. Our technology stack has fallen by the wayside. There's something better available, but it's uneconomic to try and switch over. So one thing that can help in this kind of a situation is to consider having a single unified platform. If you have a platform that's flexible enough to encompass a lot of these choices, right, and allow you to chop and change and go in different directions and deploy in different fashions, then that goes some way to mitigating these kind of risks, right? Of course, you need a vendor of such a platform who is committed to keeping up with changes in technology and providing you access to new stuff as it comes along, if necessary. However, assuming you have such a thing, then one unified platform should be able to help you with tactical work, so your data ingestion, your data preparation, your manipulation of data with machine learning algorithms in mind, the kind of engineering of features and so forth that has to be done for machine learning. The same platform you should be able to do your diagnostic work in. You should be able to visualize your data. You should have lineage, traceability, versioning of machine learning pipelines, data pipelines, machine learning models, and so forth. Similarly, the same platform should support the teams working on the applications directly. So the data scientists who are going to be building the models, training the models, the folks that are going to be taking those models and deploying them, monitoring of models, management of models in production, and of course the all-important predictions or scoring that the models produce that your decisions are then based on. So why should you care about this? Well, obviously there is a vast potential for value creation, right? Could transform your business. You also want to be able to maximize productivity of scarce talent, and one unified platform will help with that. Now, whilst it may seem that data scientists and data engineers are pouring out of academic institutions, perhaps less so here in New Zealand with respect to data engineers, but the good ones are still few and far between, so ones with experience, right? So you want to maximize their productivity, and the platform should support that. Again, with helping collaboration between these different types of teams. If you're trying to build out a data ops, agile, data-driven type methodology to help bring these applications to market faster, then you want these teams to collaborate. You want them to be reusing processes, pipelines, models, and so forth. So break down silos which have traditionally existed between these teams so that your data scientists, data engineers, data analytics teams, and cloud folks and so forth can all collaborate and work together effectively. So let's look at an example. Let's look at a typical machine learning pipeline in the abstract, right? I'm not really going to be talking about technical stuff in this talk. So let's consider an abstract machine learning pipeline with the goal of implementing something called machine learning model management. Now, what the hell is machine learning model management, I hear you ask? Well, it is the process in production of managing predictive models moving forward, right? So this story does not end when your data scientist produces a model for you that appears to solve a problem, right? It does not end once you get that into production and it's operating in a live situation on data, making predictions that you can make decisions on. Why doesn't it end there? Well, it doesn't end there because the underlying distribution of the data that these algorithms operate on will always be changing over time. Why does it change? Well, your customer's behavior changes, obviously, over time, right? As you implement decisions based on the predictions coming out of the models, this has an impact, flow-on effect to your customers, and their behavior will change, right? So at some point, what the models learned on the data originally will no longer be applicable today because of that drift in the data. So what do you have to do? Well, you have to rebuild the models on fresh, recent historical data so that it can capture the latest behavioral patterns in it. This is what machine learning model management is. It's the rules and processes around rebuilding and refreshing those predictive models. So this is a typical machine learning pipeline. It has a few steps in it. The early steps there, prepare data, engineering features, are often collapsed into one, but that is basically sourcing your data, preparing it for machine learning purposes, denormalizing it, flattening it, cleaning up, imputing missing values, all of that kind of stuff, and then the engineering of features that data scientists will do in order to make the algorithms, give the algorithms the best chance of finding the predictive patterns in the data. Next step is training and tuning and testing the models, a very iterative experimental phase where the data scientists will iterate over different algorithms, different parameter settings, and perhaps go back to the data, do more feature engineering and so forth in an iterative fashion. Finally, they'll be happy and you deploy the model, and then the last step, like I was saying, is the management phase, the update models. All right, so if we have one unified platform, then this platform should support the activities of the team working to build this pipeline. However, it should not dictate to them. The last thing we want to do is constrain our technical folks as to how they go about doing things, how they develop things, right? So let's take data scientists, right? If we look at these early phases of preparing data, engineering features, what do they do? What do they need? Well, to begin with, they need data. Right. The platform, ideally, should be able to deliver nice, clean, governed data sets to them at the click of a button. Last thing you want your data scientists to do is to put in a request to IT and then sit around twiddling their thumbs while IT gets around to writing the SQL queries to pull the data from the relational data sources, give the data back to the data scientists, and at that point they realize that they didn't couch their request quite right, and they have to go back to IT in order to get another data set pulled. Right, a complete waste of time. So instead, the platform should deliver that data directly to the data scientists when they need it. Then what do the data scientists do? Well, they start to take a look at the data itself with respect to the problem they're trying to solve, the predictive problem. So they'll be looking closely at the columns, the features in the data. They'll be working with domain experts to understand it and perhaps locate other sources of data that they can use to enrich it and so forth. And then they will start to clean it up and prepare it for machine learning. Those activities, or the results of those activities, are handed off typically, if you're trying to implement the data ops approach, to data engineers, right, whose role it is then to implement this into the platform. The data engineers shouldn't be constrained either, right? If they want to code that in native platform operators, they should have the ability to do that. If they need to take the code that the data scientists have produced, they should be able to deploy that directly. Again, the platform should be flexible. Similarly, when it comes to the development of the machine learning models themselves, the data scientists, like I say, will iterate a lot over different types of models, parameter settings, and so forth. Platforms should support that activity as well, right? I mean, sure, data scientists can do this in their favorite environments. They can write R code and Python code or whatever, right? But if the platform is there and perhaps it's providing a nice sandboxed production similar environment, simulated environment, then why not have the platform iterate over all of this stuff for you? So it should support that, should support the process there, and it should also support deploying the models once they're finally created. The best ones are created, platform should consume them directly. The last thing we want to do is to take a sophisticated machine learning model and have to recode it in some operational language in order for it to be deployed, right? If you consider very sophisticated models that deep learning produces, where there are sometimes thousands, hundreds of thousands, millions, or even hundreds of millions of parameters in the model, the scope for error, if you have to do some kind of recoding exercise, translation exercise, is enormous. You want to avoid that at all costs. All right, so this brings me finally to the model management side of things. That was the last little blue bubble in the diagram. Update models. I have an exploded version of that step here. It actually comprises 4 steps, right? So in order to make the decisions around when these models need to be rebuilt and so forth, it's necessary to monitor how they're doing. How well are they predicting, right? So there is a monitoring phase. To support the monitoring phase, we need to be able to compare. Compare not only a model performing, how it's performing today, compared to how it was performing 2 months ago. But also, if we are deploying multiple models, which you sometimes do, especially if you're implementing something called a champion-challenger strategy, you will deploy multiple models in parallel. And then it's necessary to compare the performance amongst the models, right? How does one compare to another? And then there is a third step there based around making a rebuild decision. So a business rule will get triggered at some point. This should be all automated, of course, right? A business rule gets triggered. At some point, the predictions are not accurate enough, and we need to refresh or rebuild the model on current historical data. Now, these 3 steps are driven by the fourth, which is entitled evaluation, and is highlighted at the top of the diagram there. We need to be able to compute numbers that describe how well these models perform. These are evaluation metrics, or they're called evaluation metrics, right? They need to be produced in a consistent manner, regardless of what model or underlying framework was used to produce the model. This is especially important if you have models coming from heterogeneous frameworks. Say, for example, you've deployed a Python scikit-learn model, and you've deployed an R model as well. They need to be evaluated in a uniform, consistent fashion. Otherwise, the comparisons become meaningless, and your decisions with respect to the best model or rebuild may be invalid. Okay, so it's crucial that evaluation metrics are uniform across different tools. All right, so I'm not the only one to talk about this kind of stuff. It's becoming more and more apparent to lots of people that such a unified framework or platform is what is really needed to aid productivity when you're developing these machine learning applications. So here's an example that I became aware of a couple of weeks ago. This is an open RFI from the US Air Force Department of Defense to build something called Streamlined ML. So this is a project to develop an open end-to-end ML system to enable rapid, low-cost deployment of state-of-the-art ML capabilities for use internally in the Department of Defense and Air Force, right? So their own data, their own applications. Their current approach is to consider each application completely independently of any other that's been done, right? So the machine learning capabilities, the processes, the pipelines are all done independently. There's no reuse going on there. They kind of reinvent the wheel every time they do a new project. So obviously, you can see the disadvantages of that. Duplicated data collection, duplicated development efforts. And that's the emphasis is mine in these paragraphs. Another problem is that different models, as they say, different models of the same problem cannot be directly compared. As emphasis mine, they lack a common means of evaluation for a given application. So all of the stuff I've been talking about, basically. And more people are becoming aware of the benefits of having a platform that takes the onus off the development team around these kind of topics. All right, so that brings me to the end of my sort of there and back again part of the talk. You know, I started off in machine learning as an academic. We looked around, and it became apparent that we needed a unified framework to aid researchers in doing research. Now the same kind of problem exists in a broader sense in the business community as well. So what are we doing at Vantara Labs? I work for Hitachi Vantara Labs. Formerly it was Pentaho Labs. We do research, development and innovation for Pentaho's applications. For the past year or two, we've been working on bringing more machine learning into the Pentaho stack, and with an emphasis on trying to make it a little bit easier to use for non-technical folks. So to that end, we've been producing something that we call plug-in machine intelligence. And my colleague Anton will be demonstrating shortly some processes of machine learning, giving a demo, and he'll be using plug-in machine intelligence. So this is basically a unified framework for data science orchestration in Pentaho. We've built support for this into the Pentaho ETL and orchestration platform called PDI, Pentaho Data Integration. So this is a tool with a graphical front end that allows you to build out data pipelines, and now we have the ability to drop machine learning algorithms into such pipelines. The nice thing with PMI is that it is completely a no-coding environment. There is not a line of code that has to be written. It can all be configured graphically. Furthermore, under the hood, it gives the user the option of choosing different underlying execution engines. So you choose yourself an algorithm, say a regression algorithm or something, and then you can select whether that should execute in Python, in R, in Spark's MLlib machine learning library, or in Weka. And recently we've added another engine that I'll talk about in just a second. And then it takes care of all of the little nasty behind-the-scenes details, what I call the last-mile data preparation that is required for different algorithms running in different engines. So no code has to be written for that whatsoever. It also has, as you can see from the screenshot, a tab related to evaluation. So it implements the ideas I've been talking about around unified evaluation across these disparate, heterogeneous execution engines. Okay, so we're going to continue to develop this PMI platform. Just recently, we've added support for deep learning, because you're not anybody unless you have deep learning, right? And you should throw deep learning at any problem that you have, because otherwise you won't be cool. So we've added deep learning support to PMI in the form of an integration with something called Deep Learning for J, DL for J. It's a Java-based deep learning engine, which has support for executing on the GPU. Other things we've added to PMI recently, we've added support for something called XGBoost. Now, I said I wasn't going to be technical in this talk, but XGBoost is a funky, what's called boosting algorithm in supervised machine learning. And since we begin having an exam at the end of this talk, there will be a question on XGBoost. So you better start Googling quickly so you can answer the question. XGBoost stands for Extreme Gradient Boosting, and it's been the go-to algorithm for folks that have competed in Kaggle machine learning competitions for quite some time now. And the reason for that is that it's, one, very powerful for structured data, and two, it has very few parameters for you to tune or twiddle in order to get good results. And it's one of the few non-neural network / regression algorithms that I'm aware of that has the ability to learn and inference on GPUs as well. So offloading processing to GPUs, FPGAs, TPUs, and so forth is also very hot at the moment. We're going to look at adding some unsupervised learning to PMI in the near future, probably in the form of streaming anomaly detection. There are some funky little algorithms for that available these days that can work on very limited resources, such as what you might have in an IoT edge application. And we'll probably be adding more deep learning as well, because TensorFlow, Google's TensorFlow library is super hot, and Keras has a nice sort of front end that sits on top of that. We've also added some data exploration and visualization to PMI. That's what this screenshot here is. It's a 3D scatter plot. It allows you to sort of fly through your data interactively and see it in 3 dimensions. All right, so I do hope you enjoyed my little ramblings on machine learning today. Feel free to ask me questions at the Q&A session at the end. But now I'm going to hand it back to either Neil or Rakesh, and I'm not sure. It's Rakesh.
Do you guys want a 5-minute break, or shall we continue? Okay, 5-minute break. There you go. Hello. Okay, guys, we're going to kick off again. Don't forget that. Yeah, that's it. Yeah, cool. Thank you. Okay. So guys, we're getting towards the end of our presentation. What we're presenting, demonstrating is a London air quality demo. So we're going to go through that, and then post that we're going to go through a credit card fraud detection demo. And then final wrap up after that and Q&A. Now, this demo, just to give you a bit of an overview, it's a live demo. So we are connecting through the Clifton's internet and connecting to these air sensors and extracting the demo, data out. And what we've done is, instead of writing probably a couple of thousands of lines of code and going through that with you guys, which will be fairly boring, I would say, or could be exciting, we're actually going to just use Pentaho because it just gives you the visualization and the flow around it. For demo purposes, we've kept things fairly simple and light. As you know, when you prototype, you keep it fairly light to show the value of data. So we've got Pentaho and we've got a Postgres database. Postgres is on AWS, it's known as Redshift, or Cosmos DB on, sorry, not Cosmos, there's SQL Server on Azure. But yeah, it's very similar to SQL, okay? But once you move from a proof of concept or proof of value to production, usually the architecture is slightly different. So you would bring in something like Apache Spark, you'll bring in Kafka, because you'll have more events. And then you might have a more scalable database wrapped around it, or data store, depending on the situation. But for demo purposes, we're going to keep it fairly simple today. Now, this is called the London Air Quality Demo. The City of London actually has sensors that you can openly access. You can Google them up right now and identify them. And what we're going to be doing is we're going to be bringing, the purpose of this demo is to show the value of a variety. Okay, so we're going to bring in unstructured data, or semi-structured JSON data, and then we're going to enrich it with structured data, which is postcode data. And then we're going to basically transform it, cleanse it, prepare it, and then visualize it straight away in a tool. Now, just to go through the flow at the top, so the top line is all about accessing those JSON APIs, okay? And there's 228 sensors that we're going to extract data from through the internet. Now, the second line, which is the flow, that's called a data flow, is basically the postcode data. So we're going to do some transformation. We're just going to give it a bit of a cleanup on the way. So remove all that extra information that we don't need. Normally, you would store that data and then clean it. So you would do ELT. And then we're going to actually enrich it, look up for postcode, look up, extract information regarding postcode, and then enrich it in the next line. Now, the last line is all about data preparation. As you know, like in a spreadsheet, once you get data in there, you do need to clean it and prepare it, give it some color, some formatting, some metadata wrapped around it. So all we're going to do is create a time series stamp around everything. And then we're going to write to a table, and that table is Postgres. But that could be easily S3 storage, or even could be ADLS on Azure altogether. So Mr. Anton, if you could kindly run the demo. So we are going to plot this in real time as it flows through. So we can actually see it's connecting to 228 sensors, pulling that information in. And if we jump to the visualization, oh, there you go, something went wrong. Just as a heads up, that visualization, it could be anything, Tableau, Click, Power BI, whatever you want, Grafana. You can connect to that database. You should be able to visualize it. In this instance, we're using the Pentaho business analytics, which is out of the box, and it supports more real-time insights. So on the left-hand side is just a line graph articulating time of day and pollution. On the right-hand side is, sorry, probably the other way around for you guys, is the heat map. Now the heat map is being updated as we're ingesting the data into our database. Now, on the top, we've got some basically categories. So species, PM10, PM25. I'm not an air quality specialist, so don't ask me too much about them. And we've also got areas within London, so industrial, suburban areas, a definition. Now, a lot of councils around the world have started embedding insights to citizens. So usually BI is within the business, it's to yourself, but you want to build an app, so you embed it outside straight away. And in this situation, organizations are automating the whole flow from the sensor all the way to the inside, and then exposing it securely back to citizens, okay? So all you have to do is govern the data. So City of Copenhagen, City of Chicago are two councils that are using this tool right now or doing the same approach with a whole bunch of things wrapped around it, not just the tool itself. Now, the use case would be, I've had a kid. I live in London, which is probably a lot of Kiwis have gone through this, either come back here or stay in London. But I want to buy a house, and air pollution is quite important. Understanding air pollution is quite important for me. Not pollution is important for me. The key thing is I could jump onto this dashboard from a council, identify areas that have less pollution, I guess, in the situation, and then use that to make a decision about buying a house. Now, the question here is whether you buy a house with a place that's actually got a sensor or a place that doesn't have a sensor, but that would be up to you to interpret that, okay? Because if it doesn't have a sensor, you don't know if there's going to be pollution there at all. Now, that's an example. In this situation, we use the London air quality, which was pre-built. But our partner Motive also builds a lot of devices. So this is a device, I'll pick that up later. It's for a box creation company or manufacturing company. I think you guys all know that, Aurora View. So we can easily extract data from something like this. And this device here basically does predictive maintenance for Aurora. So when there is an outage, it can cost millions of dollars because box manufacturing for fruit suppliers is quite important. It's part of the supply chain. So this device does also capacity management and asset management as part of the process. So you can trigger many things off it. But that's what you could do, is you could actually create devices and start, and it doesn't matter what device you have. You can extract value from it, and you can either get an insight or trigger an experience, which could be triggering, hey, this device or this machine is going to fall over right now. Okay. So that's the London air quality demo. I'm going to hand it over to Anton, and I'll do a quick intro for Anton too. Anton's going to go through the credit card fraud detection demo, which is actually going to articulate a lot of stuff that Mark was talking about around machine learning and how to build those pipelines. Now, Anton's been with Rivera for over a year now. Anton's our BI developer and data scientist, but he's also an evangelist in the business to reshape Rivera to become more data-driven. And he's done some amazing work at delivering self-service insights across the business. He's also got a huge passion on the machine learning side, and he does love working with 3 billion rows, okay, which we're trying to figure out how we're going to get there. But large data sets is his big focus. He does come from, once Anton talks, you'll understand he's Russian. So he used to work in a large Russian bank with large amount of data sets wrapped around it. So I'm going to hand it over to Anton now.
Thanks, Akash. Well, not necessarily 3 billion rows. Any data set is fine. Overall, in the space of BI, I've been working for more than 10 years, with the most recent focus on data science and machine learning. And as Akash mentioned, I've spent a majority of my experience working in the financial area in a large commercial bank overseas. Back in that times, in the bank, one of the most common problems we were facing was fraud, credit card fraud. And by the way, how many of you are aware of what is credit card fraud? Okay, so yeah, basically there are two main types of fraud. ATM fraud, when malicious individuals scam your card and then try to replicate and use your card to withdraw the funds. Another type of fraud, when your credit card data can be stolen and can be used for online fraud. And I had personal examples. Oh, by the way, how many of you have heard about fraud detection systems? Oh, much more than in Auckland. So yeah. Yeah, machine learning. Wellington is a capital of machine learning, not only New Zealand. I had a personal experience with fraud detection systems as a customer. 3 or 4 years ago, I received a text message, an official text message from my bank, suddenly stating that your credit card data were compromised, and we decided to issue you a new credit card and block your old card. And of course, my first reaction was to get to online banking system and check whether I lost some of my money. And I start scanning through all the transactions, and luckily my balances were the same as I expected, so I didn't really lose anything. It was a great example of a properly working fraud detection system. Someone probably possessed the data from my credit card and tried to commit fraud, and the fraud detection system prevented him from doing that. And one of the most common ways of designing fraud detection systems in machine learning, basically we'll go through that during the demo. And fraud detection is not new, and fraud problem is not a new one. And to give you numbers, unfortunately, it's still increasing. For instance, in 2018, the total volume of fraud transactions reached, according to Nielsen report, I can give you links, around $31 billion globally. And interestingly, the proportion of fraud compared to a normal transaction also increasingly grows, which is kind of weird because many companies, retailers, insurance companies, any company involved in large volumes of credit card transactions is exposed to fraud, and they try to design fraud detection systems. But still, those malicious individuals, they're capable of committing fraud more and more often. And there are many reasons why it's happening, but one of the basic reasons, I believe, is that the more fraud detection systems we design, the better those malicious users adapt to those systems, because they know that we have those fraud detection systems. So it's not enough just to create a machine learning model, train it, and deploy it. We need to think of a way how we can prevent those malicious individuals from adapting to our fraud detection preventive measures. And we'll go through that in a demo. But before we actually start the demo, I'd like to understand how many people in the audience are data scientists or data engineers, or are working with data scientists or data engineers. And I assume others are business people or related with BI some way? Okay, and others probably just came to know something new and interesting. Okay, well, I would say this is going to be quite a technical part. After that, we're not going to deep dive into any coding because that's a non-coding approach. But basically, for the business people and not related to data science, I think the key outcome is to see that you can easily kickstart doing your machine learning projects, and you can collaborate various skill sets within one platform, data engineering and data science. And well, it's always so good to have a statistics background, but basically you don't need to be a statistician ideally to kickstart your machine learning journey. And for data scientists, one of the key interesting concepts is going to be the step number 4, how to create an adaptive supervised machine learning which can dynamically adapt to changes. So I'm going to go through the 4 stages, the stages that Mark mentioned before. The key 4 stages which you need to go through when designing a machine learning project. And let's imagine that in our scenario we have a kind of big retailer, maybe in New Zealand, let's say it's farmers or warehouse. They have both point of sales and online website where you can also make orders. So basically they are involved in both the point of sale customer transactions and online transactions. And at this first step, basically what I'm doing, I'm just preparing the data for future training, to train machine learning models. And in this example, I'm using just a bunch of CSV files, which I'm just drawing up, looking up the data. In a real life scenario, this probably should be ideally a large data set, billion rows, as I love. It's going to be maybe Hadoop or Elasticsearch, maybe S3 or HDInsight, any platform capable of storing large amounts of data. And the key part of this data set is the fraud transaction report. Let me actually quickly show you that. So as you can see, this is a very simple data set. But without such a data set, it's not possible to do any machine learning model. Because basically this is the data set which says that, okay, we had a historical occurrences for both fraudulent operations and normal operations, because this is what our machine learning models will use to learn, to study, to become smart enough to predict, to distinguish fraudulent transactions from normal transactions on themselves. And so once we've done with data preparation, with the concept of unified platform, and I'm using Pentaho in this instance, we can reutilize the same, exactly the same data preparation pipeline on the second stage. But then we can straight away connect this pipeline to a machine learning pipeline. And this occasion I'm using a PMI plugin, which Mark mentioned before. And also I'm using a so-called fast fail approach, because in this platform, these are the 4 machine learning models which I'm going to train simultaneously. So I'm not going in iterative, like one machine learning model, one programming languages, working on a node, let's do tuning and testing, going to the next step. I'm just training all of them at once because I can, because the platform allows that. Of course, we may have different skill set, like Matt mentioned, people doing Python and R, but why not doing this at the same time in a simpler way, in a way which is easier, which can be reusable by other people later on. So similar pictures which Mark showed you before. Basically, for any machine learning model, we can choose one of the execution engines. And this is happening behind the scene. You just know that you may choose one of the environments, and you don't try any line of code. And you can go through many configuration parameters instead of writing lines of code for that. And they will be different for various algorithms, for various execution engines. And another cool thing here is that, let me switch off to data mode. Actually, I haven't launched it before. The cool thing that having this all in one unified platform, you can actually start comparing the performance of various machine learning models. Will it take a while? And then probably we'll get back to this on a later stage. But the key thing is that we can assume that there is a score for each machine learning model, and let's say that each machine learning model, it just has a number, and using this number we can say that this model is better than the another one, which is very difficult when you have machine learning models being programmed in various execution environments, because we need to make sure that the way how we train these models is the same to be able to make a fair comparison, and we're able to do this. So the data are not here yet, but basically, oh yeah, data start appearing. Basically, this is an example where each machine learning model has a kind of a score. This is a percent of correctly classified instances, which is easier to understand for business people. For those data scientists in the audience, we are using some kind of technical parameters, receiver operating curves. So okay, the second step, basically all what we were doing at the first step were experiments. And it's happening in the way like you design a pipeline, you launch a pipeline, in a similar way you've seen how it launched, and you just look at the results. But in the third step, we are choosing the model which performs best. We will continue calling this model a champion model, and we are deploying this model into production. And the way how we deploy it, it's a similar data pipeline, but basically, ideally, it should be a streaming process like Kafka stream or Spark streaming. But also, this could also be a high-frequent batch process, maybe like launching each 10 minutes. So let me give you an idea of how we can actually deploy this to production. So I'm just clicking Actions, Schedule, and just choosing how often I would like to run this process. So imagine that once we've deployed our machine learning model, which is here in the step, and we've created a streaming data pipeline. Now all the transactions, all the online orders and physical orders coming into our system are going through this machine learning model. And at the output, we see these new transactions, are they fraudulent or not, and the likelihood of them being fraudulent or not. Okay, and the most interesting step, basically the concept introduced by Mark Hall, and I'm happy to present it to you here. The concept of champion challenges. So everything we've done is works, and while we were designing the things, we found data patterns, we found a model which successfully describes those patterns and is capable of predicting values. And it was done on a historical data set. Now we've deployed model and imagine that it's been working maybe for a month. And the malicious users, they will understand that something's happening. They can't commit fraud that efficiently as they could before. So we'll start think, maybe chatting between them, and we'll discover that they should behave a bit differently. Their behavior will change. That's where coming up the dynamic adaptive model management. This is quite a complicated diagram, but on the top you can see it's a similar data pipeline. I'm not going to go through that. I'm going to focus on this. So basically, this is the champion model. It's the same model which we deployed on the previous step. This is the currently working model. And at the same time, we're continuously retraining other 4 machine learning models. And we are capable of doing comparison of our champion models with the performance of other machine learning challenges. And we can do this because in unified platform, we are capable of comparing similar evaluation metrics, which is really, really cool. Data scientists and engineers should be really excited. Well, and for the business people, as I would say, the key takeaway here that basically imagine that you're collaborating with data science and data engineering teams, and various people can easily work and share their work deliverables between them, and this is in general accelerates time to insights and reusability. Okay, this is all the backend of the solution. Now let's jump to some visuals. And when I was preparing these visualizations, I was actually asked to bring some scatter plots or some other fairly popular pie charts, etc. But really that's not about a variety of visualizations. That's about data patterns. For instance, in this visual, this is describing the phase which actually goes even before the exploration stage, before we start training models. Data discovery phase. When we look at the combined data set and start looking for parameters which influence, which are correlated between the type of transactions, fraudulent transactions or an ordinary transaction. This visual shows us the dependency between the type of the order and the proportion of fraud transactions. So light blue is the color related to fraudulent transactions, dark blue is normal transactions. As you can see, there are more fraudulent transactions in this data set, which were made using an online order management system. And which seems to be quite natural because it's easier to place an online order than trying to replicate a credit card and trying to steal money in the ATM. And another interesting correlation example is that the customers who just registered on the website, the first-time customers, they are more likely to be fraud customers who will try to commit fraud. And this is my favorite one because the shift toward the age of the customer trying to commit fraud is quite significant, as you can see. So basically, teenagers or maybe students who haven't yet managed to earn money on themselves, they much more often appear to become fraud users, unfortunately. And another interesting visual is when they're trying to do those online orders and register on the website. This is the time of the day when they're likely to commit fraud. As you can see, there's a slight shift, probably when their parents are sleeping, they're logging into internet systems, hopefully not with their credit cards, and trying to commit fraud. And this is just the 4 parameters from the whole data set. Actually, I used 15 parameters to train that machine learning model, 4 machine learning models. And so I could put like 15 visuals over here. And what machine learning does essentially, it basically creates a balanced opinion how to understand based on many variables, many parameters, is a transaction fraudulent or not. And once the users adapt to changes, malicious individuals, you won't see those obvious shifts in some of the parameters. So this is the way we will have to start retraining the models, looking for new data patterns and new discoveries. As I mentioned at the beginning, it's very important for many industries related to a huge number of fraud transactions. And not only just for financial institutions, for insurance companies, healthcare. But from a machine learning perspective, this is a two-class classification model where we distinguish between fraud transactions and normal transactions. Another popular example may be spam detection systems. Is your email spam or a normal email? Or it could also be a recommendation engine. Should I, Netflix, recommend this film to my customer or shouldn't? And actually, there are many numerous examples, and I'm happy to dive into the technical details of this demo during the Q&A session. And also, you can check an amazing blog post from Mark Hall, who actually introduced originally the concept of this demo and the for challenges model. So yeah, in a nutshell, it is. Questions are welcome during Q&A session, and handing over back to Akash.
Thanks, Anton. So we're going to go through final wrap-up, but just a story. Moving data from a data engineer or BI developer to a data scientist is quite a lot of work, and it takes a lot of sprints. So if you do agile, it can be 3 to 4 sprints. What we did was we had 4 different models. There would be 4 different epics potentially, or 4 different sprints, and we've converged that into one. So it's really improving the productivity and failing fast or succeeding very quickly. So that's the capability that we articulated there. And that can cost you millions of dollars, because a sprint is usually 3 months. Sorry, to get an outcome through a couple of sprints is usually 3 months. So you had the ability to actually pull all your models into one sprint and verify which one is the best straight away. Now, we're just double checking. Okay. Couple of tips. So I'm gonna go through my journey in Australia and New Zealand and sort of articulate from a business perspective and also from a technology perspective how to get started, because it's not easy getting into this big data, machine learning, IoT world. And I've made mistakes, as I sort of highlighted. And I'm sort of talking through my mistakes today as much as possible. Couple of things. In New Zealand, in Australia, volume seems to be a bit more easier to focus on because usually it's 5 times bigger from a market perspective, so 5 times more data. Now, for New Zealand, focus on variety. So currently, you may not have unstructured data. So how do you bring in unstructured data with structured data? And then focus on velocity, so time to insight. So if you're not getting those insights in your business, how can you actually get those insights or serve those insights back to business users as quickly as possible? Okay. Now, the last one is business value. Business value is so important. A lot of technology projects that I've worked on has been technology-led, and that's okay. It does work eventually. But if you start with a pain point or business problem, then lead to the technology, you're going to get the outcome faster, and your stakeholders are going to be more happier and probably are going to provide you more capital funding as part of that process. Okay? So always start with a business problem in the organization. The other thing is start with a simple use case. Although machine learning is hot and deep learning is even hotter, but I still think you've got to lay the foundation. So start thinking about what are the simple use cases, and I would recommend in New Zealand is self-service analytics will probably be your biggest. How can you deliver self-service analytics to your business very quickly? And that will lay the foundations of the technology, the processes, the methodology wrapped around it. Okay? The next one is break out those functional skill sets. One of the key things is a product owner or product manager, whatever you want to call them nowadays, getting them to chair everything and take the business side of the complexity away from the data engineering and the data scientist. Okay? So make sure they can actually lead the charge around the metrics that are being measured. That's one role I haven't highlighted up there, but it's extremely important to have a product owner or product manager. And you don't have to hire for one. You could become a product manager or product owner if you wanted to. Now, data scientists and data engineering. Now, my recommendation is don't go and hire a team of data engineers and data scientists. That's the wrong way of tackling it. Done that before, and when the platform's not ready, then they run away. Okay? So you've got to lay those foundation blocks before you get to it. Now, with data engineers and data scientists, data science as a function, you can predominantly most data scientists can do a better data engineering, like Anton's done in our business. So you can start there. And then as you scale out and get more machine learning and more larger data, then focus on data engineering. The next one is use cloud and tools. So don't go into a 400 node cluster and hire 300 data scientists and start chipping away at solving that problem. I wouldn't start there. Start small. Start on cloud. There's plenty. You can put your credit card down right now and get stuff for cents or minutes, dollars and cents off the cloud. Okay? So that's my recommendation to start there. And your proof of concept is always going to be different from your production environment. Okay? So don't try to build your production environment up front and then do a proof of concept on it. Start with a POC environment, which is all stitched together, and then work towards production after that. And you may have to strip everything back and rebuild the architecture, but that's fine. The key thing is failing fast is quite important. Someone's thinking why I stated that, but things like Kafka, you may not need things like Kafka at the start. But once you get into production, you may need a messaging bus because you have more events coming in as part of it. And unproductive resources are more expensive than technology. Okay? So start thinking about what that unified platform looks like, because you may want different tools on top of it. It could be Power BI, it could be Elasticsearch, it could be Cloudera. So you've got to figure out what is that unified workspace for your business. I don't know where the feedback's coming from, but I'll stand here. Okay, use methodology. The last thing is hiring a data scientist, and this is a problem I've been talking to Victoria University about too. The same challenge is most businesses are not sure what to do with the data scientists once you hire them. Okay, how do you actually get value out of them? How do you actually create and nurture an environment so they can become productive? Same with the data engineer. Okay, so one of the biggest challenges is building that methodology around it. And there's CRISP-DM, there's TDSM, there's a whole bunch of methodology that you can extract from the internet and get consultants in to deliver. But my recommendation is there's not one size fits all. Okay, I usually find Agile works as long as you've got accessibility to the data and the platform ready. Then Agile works because you don't need to go back to the business and continue to ask for that spreadsheet ever again. As long as you automate, that's the main thing. So I would try Agile. But the other thing that's worked really well, and I'm not a UX person, and UX to me sometimes doesn't make sense, but that's personally. But service design, which is a concept or methodology, is about what is your customer value that you're going to deliver at the end of delivering this product or this service or this insight. That works really well. Taking your entire business on that journey together through a service design framework will help you in the long run, especially when you need more money. And the last thing is do measure. Do learn from your mistakes. Do accept failure too. You have to accept failure in data because it can be hard. Sometimes you may not have all the data that you need. But also do celebrate your success at the same time. Okay? So that's sort of the high-level tips. And the technology itself underneath it doesn't really matter if you've got the people and processes and the right mindset to deliver it at the end of the day. Now, value through use cases. We could be here for another 2 hours, but I think you guys want to head back to work. But there are thousands and thousands and thousands and thousands of use cases. So if you have a specific area like banking, finance, government, and you wanted to actually understand what other people are doing around the world, do reach out to us because our partners have plenty of case studies that are global case studies of what they're doing overseas. Okay? But really, it comes back to the four bubbles that I talked about at the start. It's the customer engagement, operational excellence, innovation, and reduced business risk. Now, all four pillars are usually in your board paper. Okay, so if you're a commercial organization, your board will be focusing on one of those elements. And then you can work your way backwards to which use case is probably valuable for your business at that time. That's my recommendation. Read your board paper if you want to look for use case. The last thing, okay, so Rivera CCL. We've merged in the last couple of weeks. This is the data portfolio vision that we've built in the last year or so as a team. So this is not just my vision, this is the team's vision together. We want to re-engineer your data for the cloud. Okay, so we understand you already have data in spreadsheet or on your laptop, in emails or on your phone. But what we want to do is re-engineer it to get value with modern data platforms. Okay, so that's the value add we're focusing on. So predominantly platform as a service is our key area of focus. We want to become the best at data engineering. Okay, and that's a want to become the best at data engineering in New Zealand, not globally. Okay, so getting data out and putting it into format on cloud Open source databases like Postgres or cloud databases is what we really want to do well. Okay? Now, with the vision, there's 3 pillars. There's adaptive data. We want to help businesses pull data from anywhere. So inside or outside your business, regardless if it's structured or unstructured. Okay, so that's our focus area. Number 2 is adaptive cloud. We want to make sure we build the data, the database, the data store, the analytical processing framework closest to your data or closest to your business. And that could be on AWS, could be on Google, could be on CCL Cloud, could be on Rivera's Cloud, could be on Microsoft Cloud. We're going to be agnostic. Okay? And the last thing, which is probably the most important part, is we want to deliver insights to any user. Okay, so any insight to any user. And when I sort of articulate insight, is Uber's predictive or search pricing is actually not a report. It's an app. So we also want to focus on delivering experiences through Apache Spark, which is what Uber's doing right now. Okay, so and a user could be outside your firewall. It could be the citizens, or it could be your customers, or it could be your customers' customers. Okay, so it's not just about business intelligence at the end of the day. Now, this won't happen without our partners. Okay. So we're not going to be coding all of these things from scratch and forming it. That's not the business we're in. We're going to work with strategic partners to build this out. So some of the strategic partners on the left-hand side are Snowflake. We've got Confluent, Elasticsearch, Cloudera. We're the only MSP partner in New Zealand as part of the Spark Group. And we've also got our Spark IoT partnership. So if you needed some network mediums to actually ingest data through the Spark network, either LoRaWAN or Cat-M1, we can also assist you on that journey too. We've also got cloud native solutions. You can work on AWS like Redshift, Aurora, S3. The list keeps going on and on because there's a product every week from them. But we work quite closely with AWS and Microsoft. And Google's a new partnership that we're forming and training ourselves up on right now. And then we've also got our own cloud stack. So the New Zealand hosted cloud environment that Rivera has, the all of government infrastructure, and the CCL Polaris stack. And from Adaptive Insights, right now we've only got Pentaho, which is a strategic partner from Hitachi Vantara. So they have sponsored today's event, and that was the tool that we demonstrated everything on today. So that's our vision. What I also wanted to wrap up with was, I use this in, I do a lot of talks at universities because this is all new, and we've got I want to help nurture the next generation of students to actually understand this, because they've got to drive this forward for us as New Zealand and drive New Zealand forward. But same applies to everyone, because this big data space or open source space is not easy. Even cloud is not easy. Trying to get a production deployment of cloud is hard. Proof of concepts are easy, always. Now, I still think that everyone needs to go back today and push those boundaries, okay? Ask the questions about, why am I not getting that report? Why does this insight not look correct? How can I automate it? How can I get it every 5 seconds? Okay? So you've got to push your business to think differently, or yourself to think differently. It doesn't only apply to business as a whole. You have to be persistent. One thing I picked up as product managers is building business cases that you do get knocked back the first time around. You just have to be persistent and continuously work on that vision, okay? The next one is teamwork. I haven't seen a single project ever succeed without good teamwork. Teamwork is extremely important, okay? So you have to value the data engineers, the data scientists, and the product owners, and you need to do your part in that journey. You can't do it alone, because you'll never, ever get it to scale if you do it alone. And celebrate. One last thing is celebrating your success is important as a team, because we forget about it. We're into day-to-day operations, as everyone is. But also celebrating your failures. I find out if you celebrate failures as a team, you actually understand what mistakes you made. Okay, so that's the other recommendation that I have for everyone, is to do that. And the last thing is, I can do it, not I can't do it. Okay, and you have to be persistent and have the vision wrapped around yourself. And the final closing bit is, data is the gravity that holds New Zealand together too in some parts, and your business and your organization. Are you stuck in one place? And how can you move to the next step? So I'm going to leave that final word with you guys. That's it from today from us. Hopefully you enjoyed the presentation. We do have a LinkedIn post. If you want to comment on there, positives or negatives, welcome to. And we're happy to take feedback personally. We are just going to go straight into the Q&A session. if you guys don't mind. So, and then after that, we're just going to be hanging out for half an hour. So if you wanted to have a chat one-on-one, we're welcome to. Now, with our Q&A, I'll just invite Anton and Mark, and we've also got Salman, who heads up Hitachi Vantara for Asia Pacific. He's down from Singapore. And one of the things I was thinking is maybe Salman sharing some of the use cases that globally he's been developing on open source technology, which is quite nice. So I'll get Salman up here too to talk about through that. Come on. So maybe with the first talking through the use cases and then Q&A straight after that. Okay, Salman, I'm going to hand it over to you. Maybe talk through.
Sure. Thanks a lot for having me. As Akash said, my name is Salman Sim, and I run the analytics and IoT business for Hitachi Vantara in APAC. I guess in terms of use cases, can I just have a sense of the audience here? Are you majority from the government, since this is Wellington? Yeah, all right. So I've been through to quite a lot of government meetings such as this, talked to a lot of customers about big data strategies that they have. And I think I cannot underscore enough, and I don't want to take away from the limelight that Mark has shown onto the AI machine learning world. That's very, very exciting. I think everyone's very excited to embark on projects like this. But I cannot emphasize enough that every time I meet a government customer or prospect, that some of the basic challenges they have has always been about sharing data. Now, sharing data is an extremely complicated problem. And unfortunately, it's not a technical problem, actually, because we've had no problems bringing data into our environment, blending it, analyzing it, and doing stuff with it. But I think the challenge about sharing data is the responsibility that we feel when we own data on how it should be used. And people tend to guard it or protect it for the sake of the content of that data. And oftentimes, these silos are not physical data silos, they're more about political silos. People want to keep data separated for certain protection and governance purposes, but also people want to keep data because they feel that this is the data that the application produces, so therefore they don't want to share. So I'll give you a very simple use case, a particular customer that we have. They were trying to solve a traffic problem, and they deduced that this traffic problem was caused by tree pruning done at the wrong time. So if you start doing tree pruning at a certain time, say at peak hour, you tend to cause congestion because you close up one lane, and a 3-lane highway now becomes just 2 lanes. So traffic congestion builds up. They also hypothesized that maybe one other problem is roadworks take place at the wrong time. So at peak hours, if you close off one road to do pipe repairs or something like that, they close off the road, again, it causes congestion. Now, these few symptoms that I shared cuts across multiple departments. In this case, the National Parks owns the data about when tree pruning happens. The second one was the Land Transport Authority that owns when the contractors are doing repairs. And then the third one was Waterworks Department that takes care of when the pipes do get repaired or things like that. So we embarked on this project thinking, oh, that's quite easy. 3 data sets, 3 different departments, combine the data together, work out when the time is scheduled, and then get everyone to reschedule the time so that it doesn't coincide peak hour. So that was what we thought the problem was. Wrong. The problem was we couldn't get the 3 departments to share with us the data. No one wanted to give us the data. Everyone felt that the other department should give them the data so that they could do the analysis and then produce that. So we were really stuck in the middle trying to solve that. So when we realized that the problem was mostly about people and the comfort in sharing data, we used the platform that we have to take a slightly different twist. We decided that we would create something called a data exchange. And the idea behind a data exchange is a bit like a librarian. If you go to the library today, if you remember what it looks like, it's a big building with a lot of books in there. The librarian will be there to answer some questions that you have. For example, you could walk up and say, I want to look up a book on World War I history. They'll tell you, okay, this is found on level 3, shelf number is 317.01, something like that. And then you go and get the book, right? That's what the librarian does. But the librarian doesn't actually know the content of the book. Does he or does she? They don't. They just know where the book is found. And they know that such a book on World War I history exists. So that's a bit like what we did at Data Exchange. We made the data exchange a librarian. it would know what data is available from which department. So this way, if you ever had a problem, you could go to this data exchange and find out which government agency holds a data source that could be valuable in solving your problem. But the data exchange, like the librarian, doesn't know what data is in there. It just knows that it has certain amount of data, metadata we call it, data describing data. So it could say that we know data about when pipes are repaired. We know data about when tree pruning happens. We know data about when road accidents happen or when it will rain. But they won't give you the data. Now, we did this because when people share data about data, they're less worried about it. Right? So what this data exchange allows people to do, or allows us to do, is to be able to trawl for metadata from every single government agency and expose that to everyone else. Now, the comfort they get is you can't access the data until you ask for it. You can't access the data until you ask for it. But at least when you begin trying to solve a problem, you know where to find the data. And this is very akin to our human nature, because when we have a problem, what do? We go to Google, we search for it, we browse through articles. What's the best way to cook half-boiled eggs, right? You look through that. Why? It's not because they're authority, you're just browsing through content, and then when you search for what you think you like, you dive into it, and you read the contents after that. Now, in this case, Google gives you unfettered access to any data. But some academic journals, you have the title, but you can't read the article. You've got to pay for it. So we adopted the same thing. The data exchange trawls government agencies, pulls all the data describing data that they have, load it into a data exchange, and allows people to browse for the data. Now, this is an important psychological impact because it encourages sharing. Because when they share now, you're not forcing them to pipe unfettered data into a massive data lake. You're just asking them to share the data that describes the data. And once they begin sharing, that's the first big step, as you know if you have kids. Once they begin sharing, they begin to work together to solve the problem, and then become less worried about combining the data together, and then eventually you get to your business outcome. Right. So to complete that story, we never successfully finished that project because what happened was everybody still wanted it, and we took a long time to build the proof of concept. 1 year later, we have them back, and we have shown them that they can actually share their data on a data exchange. So initially it was tough. We faltered over the political hurdles. We worked out how to solve it. We went back to them, and then we demonstrated the value after that. So thank you very much for having me. I hope that was a useful story to share with you. Thank you.
Thanks. Thanks, Simon. Hard-boiled eggs, that's making me hungry. Any questions? So Q&A, questions for Mark, Anton, anyone in Rivera CCL? Technical questions, business questions, anything? No personal ones, though. Go for it.
I have a question about integrated data infrastructure. Have you heard about, in New Zealand there is integrated data infrastructure project which collects data from basically majority of government organizations over time. And this data source is free. You just have to subscribe with Statistics New Zealand, get project, and you will have all data for nothing. And they are linked at individual level.
Yeah, I think Salmon's concept of a data exchange is similar to that. But the part that's quite interesting, and City of Copenhagen, if you want to Google that up and go to their data exchange, which is actually Hitachi's built that out for them, and City of Chicago, is what they've done is they've automated from the source, the data source, to the transformation, and to the insight, and to the catalog. So they've taken that entire, there will be a whole bunch of processes, they've stripped that apart, and they've automated the flow, and they've made it in real time. So they've got air quality sensors or water quality sensors that you can actually get updates every 5 minutes on. So I think that's the key thing, is they've done it in a different way where it's more agile. And the other great thing that the architecture supports is you don't need to have all your data in one place. So you don't need to build a big massive data lake and start transforming the business into it. Your data could reside in SQL databases, could reside in a mainframe. So it's just the ability to go query that data and pull it out and use it. So you're not breaking those business processes, you're just extracting the data when it's required. So it's a slightly different approach to the IDA.
Just to add to Akash, one of the things that we see is people who contribute to data.gov portals, the departments already decide what they want to share. Not what they have to share, it's what they want to share. And that means that they give you only certain data sets that they have, but they may have a lot more. So the data exchange allows us to collect a catalog of what they do have so that we can actually ask them and query it within each other, the departments. Yeah, so that's the difference there.
Another question?
Yeah, it's just a just point of clarification about the demonstration you did with the Echo.
So the question was about, was it a simple process of data enrichment? And maybe what do you mean by simple and complicated process, to give me an understanding?
Yeah, were you taking, say, geographic data like a GPS location in the original data set and just also saying, okay, that links to this postcode and just shoving it in there?
Well, yeah, I know where you're coming from, but in this occasion, I've used a relatively good API, and they already had a kind of postcode, but it was a straightforward postcode, so I need to kind of simplify the data merge process. So there was some bits of data preparation, obviously, but not too much.
Mark, you got a question? Yeah, okay. So number one, Mark Hall is here post this session. So if you wanted to get book signed, he had own photos, selfies, you're welcome to. He had quite a few yesterday in Auckland. But if you want also selfies with Neil, Alte, Mark, and Ganga, so they're experts from Pentaho and Hitachi. Unfortunately today we don't have Elasticsearch in the room. Yesterday we did. And we've also got Motive, one of our partners that creates IoT devices in New Zealand. Also in the room, so if you wanted to touch base, and also myself and Anton for questions. I get the feeling there's no more questions, or is there one more question? There you go. Just being live streamed, sorry.
Oh, is it? Okay. My question is around how you, I don't know whether it's in the scope of what you do, manage the provenance of the machine learning models that you build. So what I mean by that is, you talk about creating training data sets to train your models, but then the final model that you, at any iteration, is dependent on the training data that was associated with it. So if you come up with a new model after the fact, are you able to have a fair comparison of what data was available a year ago and then train it in an equivalent way, so you get an equivalent comparison? And how do you manage that sort of provenance of models throughout iterations?
Well, we have the ability to version models and store versioned collections of data sets and models. So it is possible to, if something catastrophic happened, you could roll back to an earlier version of the model and have access to, at least metadata about the data it was trained on, if not the data sets themselves, depending on how you set up the process. So the second part of your question, I'm not too sure I completely understand. So you're concerned with differences between data sets or how data may have adapted or changed over time. Yeah, I'm not too sure how to answer that. I mean, we can do comparisons between data sets to see, how distributions have changed and so forth. That would be of interest from a data exploration or understanding perspective. Is that what you are getting at?
I guess if you're coming up with a challenger model and you only begin that evaluation process using the new data, like sort of from here on.
You could always go. You could always go back. I mean, if you start off with one set of models and then your data scientists start jumping up and down because Anaconda and scikit-learn have come out with a great new algorithm that they didn't have back in the day, you can absolutely go back and and replay the training process using old data with that new model, and then get a feel for how that all compares. Yeah, it's flexible enough to handle that kind of scenario for sure.
So your solution is to sort of version the entire data set.
Yeah, basically version the whole pipeline.
Right.
Yeah, including the models, yeah.
I have another question about machine learning, how it is usable in social science. Human behavior, can we predict, can we do anything or develop model, or health sector? One example, can we predict, say, in the emergency department whether the patient die within the next 30 days?
Can I share a use case?
Yeah, I do actually have the health, the social sciences side of it, human behavior. Undoubtedly, people are using machine learning for that, right? With tragic events just recently, obviously, it's not a solved problem by any means. However, the healthcare side of things I can address more directly because I have been involved in the odd one or two. So yes, it is possible to build fairly straightforward machine learning models to, for example, estimate when perhaps an outpatient may need emergency readmission to hospital. And we worked on a particular application for in the UK for a primary care trust there where they wanted to do exactly that. They had a patient database, right? They had access to various data sets. They had general practitioner data. They had emergency admission data. And there was a third data set that I forget. But all of that was brought together, and they built a simple regression model, which the whole process was very simple, basically. They took a year of recent historical data and said, well, this is our ground truth. This is what happened to our patients over that current or most recent year, right? This person got readmitted to hospital, this person didn't. Then they looked 2 years further back into the past and built out patient profiles based on that earlier 2 years of data. So what kind of medications were they taking over what period of time? How many emergency admissions did a certain person have or didn't have? Were they a smoker? General demographic data and so forth. So they profiled the patients, much like these CSI crime scene investigators profile criminals, right? So they profiled their patients, descriptive profiles, and then they built a relationship between that early 2 years worth of profile data and what actually happened in the current or most recent historical 1 year. And then the models would forecast for the coming 12 months and say, and then you could rank all the patients, right? And that's what the reports were. Reports were handed off to nurses and doctors saying, look, these folks here at the top of this ranked list have the highest likelihood of needing emergency admission to hospital. What preventative things can we put in place? Send people out to their homes, reevaluate their medication, all the rest of that kind of stuff. And they were able to reduce the emergency admission to hospital, save millions of dollars, basically.
We've got a diabetes demo that we didn't show, but that articulates how to actually provide or use machine learning in healthcare. So it predicts the likelihood of you getting diabetes. We've got a demo for that too. We can show you.
Simple search is easy, but more complicated, you can predict with 50-50, which means
Yes or
the
no?
model always works.
Correct.
Sometimes.
I have a question. If you know the library Luigi created by Uber, and if it solves the similar problem like your platform, and if you could compare it, the advantages, disadvantages, and so on.
Unfortunately not.
Luigi?
I really don't know much about it.
Okay.
Any other questions?
Are there any really good examples of Kiwi organisations doing ML today that you can talk about?
Thinking that through. Not machine learning right now. In production. Yeah, I don't know. So there would be some SaaS deployments, I guess, but that would be more predictive versus proper machine learning, like with GPUs and continuous learning built into it. I don't know anyone doing it in a production grade environment yet. The telco I used to work for, they've kicked off with chatbots and sentiment analysis, so they already got that in production. But yeah, not to date. There's a lot of proof of concepts out there, I would be honest, yeah. But production is a different world altogether. Mark, do you know of any? Anton?
Well, I've heard about one interesting use case, but actually those guys who were attending the session today, I think it was Bruce Curious. So basically the Frontier company, milk products, they have to predict how the grass will be growing to be able to predict whether it will be enough to feed the cows. So this is a very simple example. It depends on many factors, like the weather, etc., climate data, essentially. And basically it will influence the revenue as the final outcome. And yeah, actually I believe much more, so maybe later I can find more examples.
Just on that, machine learning does require you to automate the data flow. Usually that's most companies that I'm talking to are right now looking at Kafka or Flavka architectures to feed the data into the model. And then it's proper machine learning. It's not a once-off situation, it's a continuous learning environment. Yeah. Any other questions? Okay, thank you very much for your time, guys. And we'll be hanging out for 30 minutes if you have any questions. Thank you.